This one is a real fun one. We're going to make a type called integer that takes the type t that inherits from number. And if t is an integer, return it. Otherwise, return never. So in this case, integer means a number without a decimal portion. So just a whole number. It seems like this should be very easy in a way, but I find this one to be very tricky. And see, we have some examples here. If we pass in 1, we get 1. We pass in 1.1, we get never. 1.0, but we'll still get 1. So that could be a tricky one. A3 could be a little bit of a challenge.
Number.
Right. If we pass in, notice here, type of x is number. So integer with type of, if we pass in number here or type of x or whatever, it should return never. But if we say that number as const, then it should work. So, and I spelled integer wrong down there. Okay, let's go. What do you think? Where would you start with this?
Interesting. These last two, A4 and A5, are a little.
It's basically, yeah, I mean, this one is basically just like saying it's another way of putting number in there. And this one is really the same functionally as A1.
Yeah.
A5 and A1 are pretty much the same case, just phrased differently.
Okay, and you've got the generic. T extends basically anything, right? Just T.
Yeah. Yep, there's no generic constraint. You can, I think there is, I'm going to show a solution that has a generic constraint, but you don't need one.
Yeah, technically the solution should work with any generic. The constraint is here for which ones you operate on.
Oh man, I don't know if you're going to, I just have to say to anybody listening, I definitely was not able to do this without looking up a solution. I'm looking on the other screen. Opender hasn't seen solutions to these. I'm looking on the other screen at 3 different solutions, and all 3 of them are like, holy cow. But if you'd like me to just show you, I would be happy to show you because there's plenty to talk about. They're pretty interesting.
Yeah. I want to give it a good attempt.
All right, go. Let's do it.
Yeah. So we're essentially taking we want to do a type of check.
Mm-hmm.
Type of t extends number.
So there's no type of we can do because t is just it's not a, yeah, okay. T extends number, that's legit. We could do that.
You're right, t is a real type, yeah. Okay, t extends number. If it doesn't extend number, then return never. If it does extend number, we want to check if this is, yeah, you're right. This one's an interesting one because.
Okay, can I show you the best answer first? It's 3 lines. It's really elegant, but it's so fun. I won't force you. If you want to keep struggling, I'm happy for you to keep struggling.
Yeah, I'm gonna struggle.
All right.
So t extends number. I guess if we're talking through this, like I think this handles most of the other ones. It's like between these two. How would you?
So I'll give you a hint.
Differentiate between these two.
So we can try to filter out floating point numbers like this.
Okay. And you.
So we'll turn t, like we've seen this before in other ones. Like we'll turn t into a string, right? But we have this error here. T is not assignable to string or number or big int or boolean or null or undefined because it's undefined. So what we can do is do this. We can kind of and it with number. So we're saying if the union of t and number, which if it's never, then if it doesn't match, that is to say if it's not a number, this will equate to never, and then never in here will always, it works, but it will always go to the false case, and then we're going to return never anyway. because I flipped it like this, actually we're gonna do it this way. Because this is saying like we actually want to skip, right?
But doesn't this this statement here also catch into this? So, sorry, A3. Wouldn't A3 also match this condition and return never?
No, because A3 is a number. Okay, so this is a good stopping point. Like let's just look. What is integer t? It's just 1. So if you hover over A3, you'll see that it's another TypeScript trick where TypeScript looks at 0.0 things and just gives them that value. If I did that, it would be never, right? Okay. So that's something that I think is a little unexpected, but that's TypeScript for it. Yeah, that's what it works. Okay, the only one it's failing.
So 1.0 is the same as 1.
Is the same as 1. Yeah, exactly. So that's why that works. This one is failing though. What do you think you would do to fix this? So if I pass in number here, which is what type of X is equivalent to, if I pass in number, it will fail. So number and number, but it's not a concrete type, right? So that's the problem we're hitting, is that it doesn't it doesn't fit. So we're basically saying is we want to ask, is number assignable to t? Because we can't assign we can't go the other direction. Like we can assign 0 to number, but we can't assign
number to 0.
Yeah, exactly. So it'll be something in here. There'll be just one more, condition. We haven't seen anything
is it
quite.
The condition that I had before? No, I had t extends number. Yeah, that's it. It's the condition that I had in there before.
Okay.
Which is t extends number, return never.
All right, let's try it. So it still doesn't work, and the reason is because I think the extends.
We'll never reach it because of this.
Yeah, the funny thing is, like, I've heard some people say that the extends word is like a bad word. I heard somebody say they wish it was called is assignable to. So you're really close. Mm-hmm. The only thing is you have to do it this way. So you're saying, is number assignable to t? Whatever t is number assignable to it? Number is not assignable to constant 1.
Yeah. Actually, I think it makes sense if you read this first statement. If it's like, is this assignable to this pattern?
Mm-hmm.
I.e., is number assignable to this pattern?
Right. Another thing that you can do that I see sometimes, but I don't love, is some people do this.
Implicitly.
It would fail. I mean, you can put any number. You can put any number you want in here. It doesn't matter, because any literal number is not assignable to t if t is number, but not a literal number. Just the keyword number. So I don't like the magic number there, because I feel like it doesn't. This is what I just typed is equally valid to anything else. That I think there's no reason you can argue otherwise. So I mean, it's if I saw this code, I would wonder what's going on. But okay,
because the actual value doesn't represent anything. It's more of the the thing that value represents.
So that's why I would prefer to put number here. Exactly, it makes it more clear what it's actually saying. All right. That is one.
This is interesting. I haven't seen this flipped statement before.
It is something. Here is my favorite. I'm like jumping up and down with the joy. Check this one out. Ready?
Yeah.
What do you think?
String t extends. What does this do? What is t?
So what this does, okay, big int.
I've not seen this before.
Big int has a special property, which is that big ints are not, they don't have a decimal portion.
Right.
So
Oh yeah, right.
so we're
So
abusing that
way
fact.
you can ignore all of these.
Right. We're abusing that fact. We're saying, is T assignable to big int? Is really what we're saying, but as a string.
Oh yeah.
You get
Yeah, I
it?
get that. Yeah.
Isn't
that's
that
clever.
isn't that just, oh man, it makes me smile. This is crazy. Also, please don't put this in your code base without lots of comments or proof that there's no other way to do it.
Yeah.
I mean, you can't prove a
clever.
negative.
I don't know if it's clear.
It's
I mean, okay, this is clear with enough test cases.
Right. I definitely agree. It's tricky, but I was so just impressed. Whoever came up with this, you are amazing. I'm a big supporter.
Yeah.
I wrote some more test cases for the third one. This is another. So let's get rid of that too. This is another one that people did. So let's go through it. They're creating this digits structure here, and they're saying, does T extend some digits and then like there's more stuff? Okay. If it doesn't, then we already know that we can exit, right? So then we go in deeper. Okay, T has, it starts with some digits, some digit. It's just a single thing here, right? Okay, so then we're saying, does T have a decimal point? Is it some digits? Because we already checked the beginning, so we know that string here, the first component is a digit. Then we're saying, does it have some string and then some other stuff? If so, then never, because we're trying to return never for fractional components. Otherwise, return T.
Yeah.
So I just think this, I don't know, it's an interesting way to kind of like work backwards towards the problem. I don't like this solution very much. I much prefer the one that we had in the beginning. Here, I'll bring it back. Let's do.
Yeah, I think it's definitely a lot clearer. But again, it's like, does it? Yeah, our solution does cater for most cases, or all cases pretty much.
Right. Let's take a look at this one. Oh yeah, it does pass. It does pass these cases. Why did I put 10? Oh, I put 10 because one of the things I don't like about the test cases for this one is that they're really like 1 digit long when there is a component. So I wanted to test that. Yeah. That's what it was all about. But anyway, yeah, there was basically no other way.
Work with strings as well. If that's a string, that should just be never.
Mm-hmm. Yep. For sure. So yeah, there was no other answers I found other than these ones. If somebody has an interesting way to solve this, I found, for whatever reason, I just found this one so interesting. We were talking about it in the very beginning of our session tonight, but TypeScript and TypeScript's type system and numbers are not great friends. There's a lot of facilities for doing string manipulation, array manipulation, object manipulation, all kinds of things like that. Numbers, you have to put a little effort into. We're not doing it tonight, but there's another challenge I did with somebody else, which basically you take in a string and take in a number and increment it. So you would pass in like increment 5, and it would return 6. And
as a number.
As a number, yes. And writing this type is shockingly difficult. It takes arrays and recursion, and it takes a lot of effort to do this, which is interesting.
Theoretically, what would you do? You'd create an array of length 5, add an additional item to it, and then get that accumulator.length.
You're going to have to watch the video.
Yeah.
It's pretty interesting.
Yeah.
It's something I wonder if it will change over time. Like in 10 years, is TypeScript going to have a lot of functions and features for number manipulation, like they have added the intrinsic stuff that we saw for strings? If any, it's just to be type x equals capitalize. Man, okay. I'm talking about these guys here. Uppercase, lowercase, capitalize, uncapitalize. There's these things that have been added which allow quite a lot of power for string manipulation. I wonder if the time will come when something like that will be added for numbers. We'll have like basic math. But we'll see. People are implementing SQL engines and assembly compilers and all kinds of things just in TypeScript's type system. So eventually, I think we'll get there. But cool. Let's keep going.
Nice.